Hello students, today's our topic is Franck-Condon principle. According to the Franck-Condon principle, an electronic transition will occur so rapidly that a vibrating molecule will not change its equilibrium internuclear distance. We are now concerned with the vibrational transition accompanying electronic transitions as well. These vibronic transitions, with their accompanying rotational or revovibronic transition, give rise to the bands in the spectrum, and these bands can be in the form of progression or in the sequence. In order to understand the Franck-Condon principle, we have plotted the three separate potential energy curves for both the ground and excited state. In the case number 1, the ground and excited states have almost same equilibrium internuclear distances. This is the ground electronic state and this is the excited electronic state. And when both of these states have the same or approximately same REQ value, then the transition according to the Franck-Condon principle will take place from its center to the center of the excited electronic state. It means the 0 0 line in the vibrational progression will be the most dominant line or most intense line, followed by the 10 20 30 with the decreasing intensities line. In the second case, the ground electronic state have slightly less internuclear distance than the excited state. Then in this case, according to the Franck-Condon principle, the transition will take place once again in a vertical manner without change any in the REQ value. Here we see the REQ value is from this to this, and here in excited state it is still constant. It means this molecule is now promoted to the fourth vibrational state. It means 40 line will be the most intense line. However, there will be more chances for the other transitions as well, and hence we will obtain the 10, 20, 30, 50, 60 lines of the diminishing intensity, but the intensity of the line 40 will be the maximum, and this is known as the progression of the vibrational transition. In the third case, we see the excited state has considerably higher REQ value than the ground state. And in this case, we can see the Franck-Condon principle is still obeyed, and then but now this transition will lead to the molecule in an very high vibrational level of the excited electronic state, and we can see the molecule is in any V is equal to 10 14 15 excited state, and where it will find itself in highly compressible state, and when it will try to relax back, then since it is reached in the dissociation limit, this relaxation will lead to the dissociation of the molecule into its constituents atom, and a continuum in its spectrum will obtain as a this region with the lines of the diminishing intensities as well. Here we have discussed all these three cases concerned. In the second case, the situation can also be reversed in the manner that the excited electronic state can have slightly less REQ value than the ground electronic state, but the resulting spectra will still be remain the same, because when this state will shift towards the left hand side, then the vertical transition will take place to this side, and it will remain the same spectrum in this case as well. As this is the most important topic, we must try to understand it, because without using this concept we cannot understand the UPS spectrum for the diatomic molecule. Thank you.